We now apply the method of partial fractions to evaluate this integral. So here first let's consider the expression inside the integral, that is 2x power 4 divided by x squared minus 2x. I'm going to simplify this expression as much as possible. So first I write this numerator polynomial as it is, that is 2x power 4, and in the denominator polynomial we can factor the x. So when I do that, I get x times of x minus 2. Now we can cancel this x power 4 with x, that is by using the exponent law. So basically if we have x power 4 divided by x, we can do the subtractions of the powers, that is 4 minus 1, and this equals x power 3. So therefore this x power 4 when divided by x is equal to x power 3. And so in the numerator we have 2x cube, and in the denominator we have x minus 2. And so this is the simplified expression. However, before we apply the partial fraction method, we see that this is an improper rational fraction. And so we cannot apply the partial fractions as like this when we have an improper rational fraction. We have to rewrite this as a sum of polynomial plus proper rational expression. I have to write down this as polynomial plus proper rational fraction by long division method. So let's do the long division of this one. First, I put this numerator expression, that is 2x cube. I write down this in the form of 2x cube plus 0x squared plus 0x plus 0. The constant is 0. And this has to be divided by the divisor x minus 2. Now we consider the first term of the dividend and the divisor. We divide them, that is 2x cube divided by x, and so this equals, we can reduce this to power of 2, so it is 2x squared. So we put this 2x squared. Now multiply this 2x squared with x as well as with the negative 2, and so when we do that we get 2x cube. 2x squared times negative 2 is negative 4x squared. Now we do the subtraction of the terms, so this will become negative, this is positive. This 2x cube minus 2x cube is 0. And here we have 4x squared. And then I put the next term, that is 0x plus 0. Now we have to once again consider the first term of the dividend or the remainder by the divisor. Here we have x. So once again we can reduce this to x power 1. So this equals 4x. We put this 4x. Now multiply this 4x with the divisor. 4x times x is 4x squared, and then 4x times negative 2 is negative 8x. We do the subtraction, negative, and this is positive. This becomes 0, and this is 8x. We put this 0. Now we can divide this 8x with the first term of the divisor, which is x. So x and x will get cancelled, and we have just 8. So we put this 8, multiply this 8 with x minus 2, we get 8x minus 16. Now we have to do the subtraction. So this becomes 8x minus 8x is 0, and here it is a positive 16. And so this is the remainder. And this expression is the quotient. Therefore, we can put this expression in the form of polynomial plus proper rational fraction as we have 2x cube divided by x minus 2, and this equals, we put the quotient first, that is this quotient expression, which is 2x squared plus 4x plus 8, 2x squared plus 4x plus 8, plus the remainder, that is 16, divided by the divisor, which is 6 minus 2. So this is the polynomial expression, and this is the proper rational fraction. And so we have written the improper rational fraction as a sum of polynomial plus a proper rational fraction. And so we can now apply the method of partial fractions to write the polynomial as a sum of partial fractions. But here this is the proper rational fraction which has only one linear term in the denominator. And this is already in simplified form. So there is no need to apply the partial fraction method here. We can just go ahead and integrate this expression. So therefore I write let me write the original integral, which is 2x power 4. This is 2x power 4 divided by x squared minus 2x. We have to integrate this, and this equals this expression which we have simplified. And so this equals the sum of polynomial plus this proper rational fraction. So can put this as 2x squared plus 4x plus 8 plus 16 divided by x minus 2, and this has to be integrated. This is the expression we know how to integrate. We can now rewrite this as a sum of two integrals. That is for this one 2x squared plus 4x plus 8. This is one integral, plus the other integral is 16 over x minus 2 integral of dx. Now we can integrate this first integral. Since this is a polynomial, we can integrate term by term. So when we use the power rule of integration, that is x raised to the power of n dx, this equals x raised to the power of n plus 1 divided by n plus 1. So using this rule, we integrate the terms one by one. So first, when we integrate this 2x squared, we put 2 times of, here the power is 2. So it is x raised to the power of 2 plus 1, which is 3, and divided by the 2 plus 1, which is 3. And then plus 4 times of x raised to the power of, here the power is 1. So when we use this rule, we put x raised to the power of 1 plus 1, which is 2, and then divided by the same number, which is 2, plus 8 times of integral of 8 or a constant is just x, so it is 8x. And then now we integrate this expression, and this is according to the formula. We factor the 16 out of the integral, and then we have to integrate only 1 over x minus 2. And when we do that, we get a natural logarithm of x minus 2, and then we put this constant of integration c. So let's put this in simple form. So this is 2/3 x cube plus we can reduce this to 2x squared, plus the next term is 8x plus 16 times of natural logarithm of absolute value of x minus 2 plus the constant of integration c. So therefore this is the result of the integral.